All right, today we're going to be checking out Delay Pro from Air Music Technology. So this is a pretty crazy delay plugin. I actually got this to use mostly on my AKAI Force and MPC, but today I thought we'd take a look at the audio unit version of it inside of a DAW, just because we've got access to some better metering and scopes, and this is kind of a hard to understand plugin in some places. I've struggled with it a little bit, but I think I've got it pretty well figured out now, and I thought I would take some time today and share with you guys what I've learned in case you want to go kind of beyond the presets in here and make your own delay patches with this pretty unusual delay. Hi, my name is Joe, and if you're new here, then welcome, and if you're already a subscriber, then welcome back. It's great to hang out with you again. So let's get into it and check out Delay Pro. So I've got the plugin loaded up here, and I've also got just a copy of Mini D here, and it's playing a very basic triangle sound, just to kind of not get in the way of anything, and so we can really hear what the plugin is doing. And I've also got this delay set up on a bus, so it's set up in like a send-return kind of configuration. And for that reason, I'm going to go ahead and turn the mix up to 100% here. I'm just kind of on an initialized patch. And let's get into it. So we start off with the two main delay modes at the top. We've got an analog delay and a digital delay. So the analog delay is kind of like a tape delay. So you record onto a tape, and as you change the speed, then the tape either speeds up or slows down to accommodate the different delay times. So if we turn the sync off here, mostly you're going to hear this analog delay, the difference between the analog and the digital when you're adjusting the time on the fly. So let's check this out. I'm just going to turn the feedback up some here so we have more echoes, more delay ringing out, and I'm going to adjust the time as I play a note into it. So you can hear that with the analog delay, we get these crazy pitch shifts, just like a tape speeding up and slowing down. And that can be pretty fun. And there are some other things in here, like the envelope follower, that we can use to actually modulate this delay time. The digital delay is a little bit different. So the digital delay, I think, is probably based on like a granular kind of delay. So as we adjust the delay time with this, we're not going to get that crazy pitch shifting effect in here like we did with the analog. Instead, it's going to sound not exactly clean, but it'll sound a little bit different. So check out the difference here as I play through the digital delay and adjust the time. All right, so that's the main difference between analog and digital. I think you're mostly going to hear this when you're adjusting the delay time. Let's flip this back to analog for now. Let's turn the sync back on and turn the feedback up some. And let's talk about the different modes that we have available to us here. So the first one is single delay. This is a stereo delay, by the way. And in single mode, we just only have control basically over the time of both of the delays at the same time. So as we adjust this delay from like a quarter note to an eighth note, if we're in sync mode, it's going to adjust both the left and right delay. And so as I play through this, I also want you to check out over here on the stereoscope over on the right that right now we're just going to get what looks like a mono signal out of it. However, in the single mode, I can kind of offset this right delay too, right? So even if I change this up to just like 1 millisecond and offset the left delay time from the right time, now look at the stereoscope over here on the right and watch what happens. So now I'm getting a stereo image out. The second mode is dual delay, and with this mode, we can set the left and right times independently. So we've got the left time set to a quarter. Let's set this right delay time to like maybe an eighth note. So you can kind of see the delay pattern over here in the stereoscope. We've also got this other mode called cross delay, and this is like a ping pong delay. And this time you can see by this little icon here that the left and right times are locked together. So if we change it for one, we're going to be changing it for both. Let's listen to what this sounds like. It's kind of a ping pong delay. So it's kind of nice. We've also got this width control, which controls the stereo width. You'll notice we've actually got two of these. We've got one here at the input, and then we've got another one down here at the output. So this, they're not the same control. One just adjusts it before it goes into the delay, and the other is kind of a final width control. So if we bring this down, we can take the stereo image and make it completely mono. And I think that gets really interesting with the dual delay because we can in effect turn this into almost like a multi-tap delay, right? If we unsync these times, let's make these kind of different. Let's maybe set the left delay at like a 1/4 second or so. And we'll make this one longer on the right side. And with this width all the way down, it really just kind of sounds like a 2-tap, multi-tap delay. All right, and finally on delay time, like I say, we can unsync these things, and these delay times actually go down really low, like into the milliseconds. So with this, we're able to turn the feedback up pretty high, and we're able to get like some carpless kind of effects out of this delay as well, if we turn the feedback up high enough. So let's try that about 99%. So we're getting like some resonator effects at that level. Before we do this, before we turn the delay up past 100%, let's turn this limiter up. So we'll talk about this in a little more detail later on, but this just basically kind of limits the output so that we don't blow our ears out. And we can make this time a little bit higher. So potentially some really fun sample material in that range. All right, let's go ahead and sync these back up. I'm going to put this back on maybe a 1/4 note. We can leave the offset alone here. We'll leave it in single mode, and we'll move on down to the next section, which is our feedback section. So we've already been playing with this a lot, but what's really kind of unusual about this one is that this feedback control goes way up, right? We can turn the feedback up over 100%. It goes all the way to 150. So above 100%, not only are we sending the entire dry signal into the feedback network, but we're actually amplifying it as we go in. So again, I've got this limiter control here set up so that we don't kind of make this get too loud, but let's listen to what happens. You can hear that the delay is actually increasing in volume. So in the manual, error tells us that even at 150%, the delay won't echo out forever. It will eventually stop. I have not had the patience to test that out for myself. It lasts for a really long time with it cranked up that loud, or with that high of a feedback. So next up, we've got the filter section, and we've got this high and low pass shelving filters here. So over on the left-hand side, we've got a high pass. Over on the right, we've got the low pass, and these adjust the signal coming into the delay. So we'll turn our feedback up a little bit more so we can hear these. So if I take this low pass and bring it down, I can make the delay signal sound a lot darker. And with this high pass, I can remove a lot of the low end and make it sound a lot thinner. And I can kind of use these together. So it is worth noting that there is some overlap between these two filters. So if I bring this one all the way down and this one all the way up, we're basically going to choke the signal out of the delay. We almost won't hear anything at all. I don't know if that was even audible over YouTube. There is a little bit of a signal in there, but it's not much at all. So we've effectively kind of overlapped these things and filtered out all of the signal here. All right, next up we've got this resonance section right here. So we've got a resonance control, a frequency control, and then we've got this modulation section over here that allows us to modulate this frequency. So again, because I'm going to be potentially getting into some areas with some crazy noises, I'm going to leave this limiter turned all the way up, and let's just bring the resonance up to something kind of high, but not too high. And let's take a listen. And I can adjust the frequency here. So resonance is effectively just kind of like feedback at the filter frequency. I don't know what kind of filter is in the middle here. I'm assuming it's kind of like a bandpass filter or something like that because it doesn't really seem to cut out much of the sound. So that gives us some really interesting tonal qualities to the delay and the feedback. We can actually adjust this or modulate this automatically with this LFO. So this knob right here controls the amount of modulation. And then this control controls the rate of modulation. So how fast are we going to sweep this filter and how much are we going to sweep this filter? But I guess what's interesting here is that I've noticed that this rate also has an impact on the amount. So this goes from very slow. It goes from 10 millihertz, which I think is a cycle every 10 seconds, all the way up to 5 hertz, which is 5 cycles per second. And what I've noticed is if you have this turned up very high at a very high rate, you won't get as much modulation. It won't sweep this frequency nearly as much in either direction. So let's just kind of take a listen to what it sounds like with the rate turned all the way up. And you can kind of watch over here on this spectrum meter to kind of see what I'm talking about. I mean, you will hear it, but it won't sweep it that much. Let's turn the feedback up. So you can hear it, you can kind of see these dancing around over here, but they're not sweeping that much in either direction. So as opposed to, let's turn this feedback up and let's turn this rate way down. Let's bring this down to, I don't know, maybe in the 20 millihertz range. And I'm going to play some notes into it again, and what you'll notice over here on the spectrum analyzer is that the sweeps much, much further. It modulates the frequency by a much greater amount. Let's check this out. You can see the signal moving over to the left into the lower frequencies. Starting to sound very percussive down in that range. And then it starts moving back the other direction, so we're going to sweep back up. Over a much broader range. And that will continue on for a very long time. Definitely some interesting sample material in there. All right, let's go ahead and bring this rate down, and we'll bring the resonance all the way down. Next up, we've got this distortion control. So this basically, you're not going to hear this unless you're actually building up a good bit of feedback, but this controls kind of, it applies some distortion to the feedback as it builds up. And to my ear, this is more like a saturation kind of distortion. It's not really like a grunge distortion or a dirt. So let's just kind of check this out with the same type of signal, and let's see what that sounds like. I am leaving the limiter on here, so we'll see what we get. Starting to hear it now. Let's maybe turn this feedback up even over 100%. So yeah, that can get really interesting. Next up, we've got this limiter control, which is expressed as a percentage, which I don't fully understand this. Most limiters that I've seen have a ceiling control, and the amount is measured in dBs, so you kind of clip it to a certain dB threshold. This one just goes from 0 to 100%. So typically what I do, if I'm messing with feedback, very high feedback, something approaching or over 100%, or I'm messing with this resonance control, then typically I'll just bring this limiter all the way up to 100%. And then if I get brave enough, I can start to bring it back down to apply less limiting. So I think that's all I've got to say about that one. Moving on, we've got this auto clear control, and this is really one of the standout features of this delay. This is a pretty uncommon feature to have in here. So let's turn this on, and what this does is it listens for an incoming peak, which I guess is basically the equivalent of an incoming note, right? Although if you're a vocalist or something, it could be kind of like the next word or something that you sing. And when it gets that incoming note, then it clears out the buffer. So what this does is lets us have like really high feedback amounts, but yet kind of keep them tamed and in control, because when we bring in the next note, then it will clear out the buffer, so you don't get kind of like discordant frequencies and pitches within that feedback zone. So let's just kind of check it out and see what it sounds like. So I've got some feedback in there now. Let me play a different chord. And you can hear it cleared out the previous buffer, so I don't have those other notes in there kind of beating against these. Which is really cool. So this threshold control, basically what this does is when you get a new note, it will clear out the buffer, and then it will wait until the feedback level in the buffer gets to a certain amount set by this threshold before it will allow it to clear it again. I think that's a really confusing way to have to think about it. The way I like to think about this threshold control is almost like a time control. So once I've cleared the buffer, how many new notes am I going to let into the buffer before it will allow it to clear again? So you can hear here I've got a quarter note feedback here, or a quarter note delay. I'm going to play some notes into here. I'm going to play 4 notes. And let's turn the feedback up again so we can kind of hear these ring out. So you can kind of hear that all 4 notes that I played are into that feedback buffer. So let's say I wanted to get less of those notes. I could bring this down some. Let's try it maybe around here. And I'm going to play 4 notes again. I'm still hearing all 4 at that point. Let's bring it down even more. And right there, I'm only getting the last 2 notes that I played into that buffer. So if I wanted to get the last 3, I could bring it back up a bit. And there I'm getting the last 3 notes that I played. So hopefully that makes sense. I think that's a more convenient way to think about it, or a more straightforward way, at least for me, to think about it with this threshold control, is like, how many notes am I going to be able to inject into that feedback buffer? All right, let's turn the auto clear back off, and let's check out this diffusion. So diffusion, I assume this is built on like an all-pass filter, or maybe a small network of all-pass filters, and this kind of diffuses the sounds inside of the delay. So it kind of blurs them or makes them softer on the edges. It almost makes it sound more like a reverb. So let's just check it out. We'll turn the feedback up again so we can kind of hear these ring out with more echoes. And you can hear it's really softened up those sounds, like the attack and release of them. It's just not as nearly as harsh. Sounds really beautiful, actually. So we've got an amount control here. To apply more diffusion. And then we've also got the size control. So the way I like to think about this size control is almost like the room size in a reverb. So if we bring this up, it's going to be diffusing these over like a larger space. So let's hear what that sounds like with a higher size. And again, turn the feedback control up. And you can hear it almost sounds like those echoes are more distant with the size cranked up higher. So we've also got a stereo control for this. It's just a button on or off, and this will essentially make it mono if we turn this off. Now that won't do it for the entire chain of effects that are in this Delay Pro. It will just do it for the diffusion. So you can see we've still got a stereo signal out of here. If we really wanted to make it mono, we could bring this width down at the output. Let's bring that back up for now. So diffusion, I really love having that inside of this delay. It sounds great here. Next up, we've got this modulation control, and it's got 3 different modes. So it's got a wobble, which is kind of like a pitch changing effect. And then it's got a chorus, and then it's got this mode called stereo, which is actually also a chorus. So this is a mono chorus. This is a stereo chorus. So we'll check out the wobble mode first. We basically got a couple parameters here. We've got an amount control, which controls how much it bends the pitch. And then we've got this rate. This is like an LFO that controls basically how fast it's bending the pitch. So we'll just try it out of the gate here. And we don't hear it very strongly there, so let's bring the amount up. And there we hear it quite a bit. And we can make it slower. So that's a really neat effect. I guess that's based on like another delay inside of a delay. Wild, huh? So you can really use this to make it sound more like a tape delay, right? Because we're kind of getting that that wobbling effect that you would get from like a tape delay kind of effect with an older tape or kind of an older player. Really nice. All right, in the interest of time here, I guess we'll just kind of skip the mono chorus and go straight to the stereo chorus. They're both chorus effects, and you get the same amount control and modulation here. I think actually for this one, let me go ahead and switch out Mini D a little bit here, and let's change this to from a triangle wave to something a little bit more rich, like a half saw. And actually, you know what? I think also let's make this polyphonic rather than a mono sound on Mini D. So we'll just come up here and change the polyphony from legato to 4 voices. Okay. So let's hear what this sounds like with the chorus, the stereo chorus. So we can make it faster, kind of a seasick chorus. Or we can make it slower, bring the amount up a little bit here. Maybe even slower still. That sounds really nice. Let's try that with the diffusion too. Sometimes I've noticed with the diffusion, it almost seems like it, you need to add a little bit more feedback to kind of get the same amount of feedback. It kind of, I don't know if it's diffused, it just makes it, the feedback decay a little bit quicker. Oh, that sounds beautiful. All right, moving on. We've got the envelope follower. So this basically listens to the incoming signal, and it creates sort of a low frequency envelope based on the volume of the signal that's coming in. And it's got two controls. It's got a ceiling right here, which is the maximum modulation amount that it's going to let happen. And then it's got a release, which goes really high. So we could send in just a plucky signal and still get a 20-second long release or decay out of this envelope. And there are three signals that we can modulate with this. We can modulate the time and the feedback and the mix. So let's check these out. Let's turn on the time, and we're in analog mode. And let's go ahead and take the sync off of here. And so this means that, when we modulate the time, we're going to kind of get some pitchy kind of effects. So let's turn this up a bit. And let's see here. We'll start with the time down quite a bit. Let's start it down maybe about a quarter second, maybe. And we'll turn this release up, and let's shoot this up to about maybe 3 seconds, 4 seconds, and let's hear what it sounds like. So you can hear as the envelope decayed over 3 seconds, the time got shorter and shorter, and it also raised the pitch because that's what analog delays do. So we could bring this up some more and have this happen over a longer period of time. And by changing the ceiling, we can have it increase the time even more. So let's bring the ceiling up to 100%. So this is going to sound really different if we're in digital mode. Let's turn on digital mode and maybe turn on sync, and let's set this to something really fast, like a 30-second note. And let's maybe bring this time up a little bit. Let's see if we can get kind of a bouncing ball effect out of this. We'll turn the feedback up some more. Let's bring the ceiling back down. Maybe start with a little bit slower initial time. That's pretty cool. Let's see what it sounds like when we turn the sync off. Definitely sounds more grainy. Okay, so we can modulate time. We can also modulate feedback and mix. And what I really like these for is kind of really taming what would otherwise be an out-of-control feedback. So let's go back to analog mode here. Let's turn the sync on, maybe set this back to a quarter note. And let's start the feedback at something pretty reasonable here, right? Like maybe 75%. But using this envelope here, I'm going to be able to start the feedback at a much higher value than that. So it actually the feedback gets louder initially, but then it'll decay away. So let's turn this way up and listen to what we got. You can hear it's getting louder initially because the feedback is over 100%, but as that release envelope reaches the bottom here. So we could have a similar effect with the mix control by turning that up and down. I'm actually not going to do that now because I'm set up with a send return kind of configuration, and I don't really want to mess with the mix, but I think you're hopefully getting the idea. All right, next up is the EQ. So this is a pretty powerful EQ that's built right into this delay effect. We've got three controls. We've got a frequency to set the center. We've got a Q control, which actually sets the quality or bandwidth of this EQ. And then we've got a gain that goes in both directions, so we can kind of notch something out, or we can boost frequencies. Let's start with it boosted to just kind of hear what that does. So we can set the frequency with this, and then we've got this Q control, and basically what this does is kind of increases or decreases the bandwidth as we turn the Q up. So we've got the center frequency, let's say it's set at 461 hertz. So with the Q set really low, we're going to affect frequencies, pretty far on either side of that 460 hertz. But as we turn it up a lot, we're narrowing that band, so we're really affecting frequencies only close to 461 hertz here. By the way, when I turn it up this far, you're actually going to hear some resonance in this as well. And then we've got this gain. Like I said, this can go positive or negative, so here we were boosting some, but we can also just notch some frequencies out of this. So you can really use this to sculpt what the tonal characteristics of the delay sound like. Very powerful filtering here. All right, finally we've got the output section here. So this has two more shelving filters, another low pass and high pass, and those work exactly like the ones over here on the filter section. They're just in a different place in the signal chain. These are on the input to the delay, and the ones over here on the output are on the output to the delay. So we can really use these to do more of a, a broad filtering. After everything's happened here, everything we've applied to it, we can shape it. Make it a lot darker. Similarly, we've got a width control. This is not the same as this width control, but it does the same thing. So we're just kind of controlling the overall stereo width at the output. So we can bring it down and make it mono. Or make it fully wide, or anywhere in between. And then this balance control just allows us to move things either to the left or right of the stereo spectrum. And then finally we've got this mix control, which controls the balance between the dry signal and the affected signal as it goes through this entire signal chain. Since I've had this set up in a send-return configuration, I've had this set up at 100% the entire time. But if you were using this as an input effect, you would probably want to turn this down some, quite a bit, probably under 50% somewhere if you were using it as a fairly standard type delay effect, but maybe more if you're going for something more esoteric. So hopefully at this point, you have a really good grasp on all of the controls and all of the signal chain that's available within Delay Pro by Air Music Tech. I hope this has been helpful for you. This is Joe. I'll catch you next time.